Hi everybody. We're going to start with our chapter 1 today. I'm going to break this chapter up into 2 parts. So this will be part 1 for chapter 1. And so it's really kind of an overview and introduction about, an environmental science as a science, some of the background about how the environment is studied and things like that. So basically the earth and the environment seems huge to us, but actually the systems and our resources here on earth are actually finite, and people can impact and damage these systems. I know that you have seen some evidence of pollution in your lifetime, and what's the cumulative pollution level that the earth can actually handle. That's yet to be determined. So what is the actual environment? The environment is all the living and non-living things around us. And when we say that we are studying environmental science, we're basically trying to figure out how the natural world works, and then how does the environment affect people, and then how do we affect the environment. That's really what the focus is of this class this semester. So I should mention that environmental science is not the same thing as environmentalism. So if we are saying that we're studying environmental science, we're actually trying to pursue knowledge about the natural world in a scientific manner. Scientists try to remain objective about that as much as possible. As far as what isn't, being an environmentalist, what does that mean? It's really a social movement, and it's dedicated to protecting the natural world. And if you look at this PowerPoint slide here, I'm wondering if any of you realize who that little cartoon character is that's standing on the tree. I bet some of you have watched that movie before. If you haven't, that cartoon, you should watch it. There are 2 versions, an older one and a newer one. And that's the Lorax, and he's saying that I speak for the trees. So lots of environmental scientists actually are environmentalists. It would be hard to be interested in the environment and not want to speak out when you see things that are not right. But generally, this is not the same. That's not what we do every day. We don't go around picketing and tying ourselves to trees and things like that. We're actually conducting and doing science. That's not to say that we aren't environmentalists on our own time, but during the daytime when we're at work, we're actually being scientists. And so who studies environmental science? And so lots and lots of different people. I'm so glad that you guys have decided to take this class. I know you probably took it, some of you because it is a Miami Plan course. Some of you, oh, well, it's kind of interesting to me. And then some of you are actually here because you're really interested in the environment. I always wish that more political science majors would take a course like this. They probably should. They're the ones that are going to be deciding on the laws that affect the environment. Certainly business majors should be taking environmental science. Business and has a huge impact on the environment, and individuals within a company can also have a really positive or unfortunately negative sometimes impact on the environment too. Teachers certainly should be aware about environmental science and the issues so they can help train the next group of citizens, and then just people who are interested and concerned. Maybe you've seen something in your own neighborhoods or in your own towns, and it bothers you and it worries you. So all of these people should have some kind of background in environmental science. So I'm really glad that you were taking it. There's always something every day in the news, always, and I laugh kind of at this picture. Hardly anybody reads a newspaper anymore. I wonder how many of you actually get a written a paper, a version of a newspaper. And I'm even surprised more and more how people don't even read the newspaper at all anymore, even if it's a digital version. A lot of students get their news in all kinds of ways, social media, little apps maybe that you've signed up for. But no matter where you get your news from, for the rest of this semester, I would really like you to every day check the news for something that is related to the environment, because it's happening every day all around you. Sometimes it's focusing on what's happening in the United States, sometimes it's somewhere else. So it's really makes this way more interesting if you can kind of keep up on what's happening every day in the news. So I thought this was a very interesting figure from last year. This shows the United States, and each one of these 14 different weather and climate disasters, each one of them costs more than $1 billion. So one of the issues with talking about climate change is the fact that people recognize there's an issue, but then they'll say things like, well, we can't afford to fix it, or it'll hurt the economy, or people will lose jobs. Well, I always wonder, who do you think is paying for all of these billions of dollars every year that we're losing? People are losing their homes, their businesses, infrastructure due to the climate change disasters. So we've always had people always have weather, but these absolutely severe 100 plus year storms that have been hitting more commonly, more frequently, those are new, and we're going to have to figure out at what point are we tired of losing homes and communities to these these disasters. Maybe we should step up and try to prevent some of them. And some of these, not all, but some of these could be prevented with some science and some understanding about what's actually happening out there. So this was in the news last year. Some of you are way better about geography than others. I'm going to wait a second to see if you can figure out what country that is. These fires started in the fall and burned through most of January last year. Does anybody know what country that is? So this is a picture of that country on fire. You can see this is from the space station. So you can see the amount. I mean, if you could see this from 2 miles up, you know that these were very large fires. Did you guys figure out what country that is? Here's a hint. Yeah, that's when Australia was burning. And so that was, a huge global crisis. It happened in that country, but all of that smoke went globally. All of those trees that burned and the forest that burned there, that added a tremendous amount of carbon dioxide to the air. And those trees now are gone, and they were, actually helping with pull CO2 out of the air. And there's a poor koala bear. You probably saw this on the news. They were showing a lot of these sad little koala bears that had been burned, and it was a very sad thing to see. And so that's the other side of all this environmental damage. Lots of times we think about it in human terms, but how many little animals, besides the koala bear, including those, how many of those actually burned alive? How many of those, have no food now because their forests are gone and their habitats have been destroyed? So it's hard to, just be a regular person and not feel some compassion when you see things like this. So there's lots of things in the news all the time. Last year, there was a toxic algae outbreak in the Ohio River and even in local ponds. Several cities had zero drinking water for a number of weeks, and some people's pets that had gone swimming, even in a local pond or in the river, and then they licked their paws, they died. Some of them just had seizures and got very sick, but others of them actually died. So there can be such a thing as toxic algae. Algae is everywhere. Most algae is not toxic. but occasionally, especially if it's been a really hot, warm summer, sometimes there are toxic algae outbreaks, and people need to be aware of that, right? You don't want to go out swimming or letting your pet go take a drink out of the lake or the pond if you don't know. So that's yet just another reason why you should be aware of what's happening. Last fall, there was quite a bit in the news about the Amazon burning. There were 75,000 different individual fires. Again, this is a picture taken from the space station. So the space station is kind of a great environmental monitor, right? We can actually see how many fires there actually are. I would like you to go to the PowerPoint show, lecture show in your files, and I'd like you to watch this video from CNN about the Amazon forest fires to see why those fires were set, what was the ultimate damage of those. I'm going to be posting your lectures in YouTube, and sometimes there's incompatibility issues with videos. If you're watching a video in YouTube, you can't watch another video. So anytime you see one of these video links, if you could please just pause and maybe even have this PowerPoint display open and just watch it. Most of them are only a minute or two long, but I know you were probably like me. You can listen to me yammer all day long, but watching a short video and seeing those images for yourself, you actually remember them a lot more. So global temperatures have been going up over time. This was all from last summer. I know some of you are well traveled and others of you are only here in the United States. Most people have an idea about Scotland and how high in latitude Scotland is. So Glasgow is in Scotland, and for a few days last summer it was 89.4. Denver, which is a mile high up out in Colorado, hit 105. Let's go look at Pakistan, 122 degrees, and these are actual temperatures, okay? These are not like, oh, it was really humid so it felt hotter. These were actual global temperatures. And when temperatures rise like this, lots of people in the world don't have air conditioning. Lots of places never had air conditioning because they never needed it. Lots of poor people live outside and have no way of getting out of the heat. And so these extreme global temperatures are definitely a concern. So now I'd like to tell you a story about what's been happening out in California. Those of you who have been following the news probably recognize that there are massive wildfires happening again in California right now as our class is in session. This is not, it seems very common to you, probably your whole life you've been hearing about these western wildfires. This is kind of new. In the last 15 plus years, there have been really extreme fire events, and millions of acres have been burned, and this is different than the way it used to be. So I want you to kind of follow the links here about how everything actually ends up becoming connected. This would be maybe a short answer or essay question on your first exam, something where I would like you to remember what we're talking about here and then tell me how it all links together, because what you're going to find is in environmental science, everything is all linked together. So let's start off with this little teeny tiny beetle. So you can see how small it is. The person's there holding one, so they're very tiny little beetles. These are invasive beetles that are not from North America. They probably came in on some shipping crates or pallets or packing materials from Asia. It's a little bark boring beetle. And we have lots of native bark boring beetles too. So it's not like it's the first one that ever got here. We have plenty of them as well. But this particular beetle actually thrives eating pine trees. They reproduce like crazy. Our pine trees that were here in North America had never seen this particular bark beetle before. It had no immunity to that bark beetle. There were no pests or pathogens to keep that bark beetle in check. Because of climate change, the temperatures in California were quite a bit warmer for the last decade or so, and so this beetle just thrived. Normally, this beetle is not very cold tolerant, but it's because of warmer and warmer seasons in the West. This beetle was able to overwinter and just it makes hundreds of offspring every few weeks, and the beetles bore into the bark. You can kind of see when they're chewing its way through, and they eventually kill the tree. It doesn't take them all that long to kill a pine tree. So all those brown trees that you see in this picture are all dead trees. So we follow up. So there's a lot of these dead trees, dead and dying trees in the forest. We follow up with a crazy 2018 where it was the hottest summer ever recorded in California. You can see these temperatures. This is very, very, very unusually high temperatures for California in the summertime. It doesn't usually get that hot. And so all of those dead trees then that were standing there in the forest still got dried out very quickly. There wasn't a lot of moisture in the other vegetation. There wasn't a lot of moisture in the soil. It had been very hot and there had been a drought for quite a long time. In 2017, this was the data I have from 2017. I've been looking for something similar for the last couple of years, but I haven't found anything that had it all mapped out like this. So let me show you this one. There were 9,000 fires, different fires, individual fires in 2017 that burned about 1.2 million acres. That's a lot of land. About 10,800 homes and businesses were burned. 46 people died. There was about $180 billion in damages. And big question here is, how did this impact the wildlife, right? There's no way to go through and count how many little birds and animals died as a result of these fires, but certainly many of them that weren't able to get away from the fire did burn up. And then their homes, right? The habitat has been very, very, very destroyed. There was a lot of press about this in the news. People trying to put out the fires. You can see the fire coming right down into this neighborhood, and a lot of homes did get destroyed for sure. There's this whole town actually burned up. There's like nothing left in that town. So I don't know if anybody here has ever lost anything in a fire, but imagine losing everything that you own in a fire. And your school's gone, your neighborhood's gone, your business where you work is gone. This is just unprecedented. This kind of fire damage is just shocking that this happened. I have this picture of this little kitty as a representative of what's happened to the poor animals, and that cat was home alone when the fires broke out, and its owners were not able to get there to save it, and at some point in time it luckily was able to escape, but you can see that its face was burned, its paws were burned, and you know that poor cat must have been very scared, and it was definitely hurt. But there's the kitty now. You can see it over there on the rug. So yeah, his ears are a little messed up and his paws are a little messed up, but the kitty's okay. That unfortunately was not the case for most of the wildlife, right? And people's pets as well if they were home. So I want you to think about that when you hear about things. You know, it's easy to watch a 1-minute segment on the news, and they usually show somebody's home burning, or they show something kind of dramatic. But I want you to stop and think about what all these fires actually mean. So after these fires were finished, and actually while they were still ongoing, the air quality in California became some of the worst on earth. And so this shows you areas that were considered to be very unhealthy, areas that were unhealthy for sensitive groups, maybe people that had asthma or older people. And a huge amount of California was considered to be, very unsafe. There's another little YouTube video I would really like you very much to watch. Again, I won't be able to just click on those and show them, because then when I post this, it won't show properly. But I think that you will quickly see what's actually happening. And remember that all that air pollution goes everywhere. So it's not just a California thing. That air pollution is being released into the environment, and that's having a global impact. So after the fires are over, what do we have? We have a bunch of dead trees. Those trees were protecting that soil. The roots and the canopy of that tree were keeping the soil in place. And then, as it always happens in California, there were heavy, heavy rains. This tends to be what happens. The fall and the winter is the rainy season. And so then the rains came, and this particular house and neighborhood had not been burned, but the slope above it, the mountain above it, had totally been burned. And all of that soil and mountain and rock and debris came flowing down in these huge mudslides. Again, please watch the short video clip about the mudslides. It completely came across, and it blocked one of the major highways in California. So this would be the same as if maybe I-75 that runs down to Cincinnati had been completely buried in mud and debris and rock. And it takes a very long time to clear that stuff away. And so that's what happened. So if we were able to all talk together and we were in class right now, I would have us do something called Think, Pair, Share. These are just questions for you to make sure that you can actually understand how things are linked together. So take a couple minutes. I want you to think about, first off, what caused the beetles to spread and thrive? What caused these mudslides? Why did the whole mountain come down? What caused the trees to initially die? And by the way, what caused the fires, you guys? What were the causes of fire? Now, a lot of people, when I say what starts fires, yes, people sometimes start fires. You're right. There are people, and in case of California last year, there was somebody who actually did arson and started a huge fire. But lots of times, Mother Nature and lightning is a cause for fire as well. So sometimes the fire is related to people or our activities. Maybe they have a piece of equipment that isn't working right, or they have a muffler that's dragging on the ground and it's making a spark, or somebody throws a cigarette out. All of those things can start fires. But a lot of times in the forest, it'll be a lightning strike that will start a fire. And when you have millions of dead trees, pine trees standing around, they are very flammable. If anybody here has watched that very funny movie, the Chevy Chase Christmas movie from a few years ago, and you saw how fast the Christmas tree burned up, that's very true. A lot of these evergreen trees have a lot of flammable contents in them, and they just burn. So what was the ultimate cause for all of this destruction? That's the big question for you. If you look at every single thing on here, there's one factor that ties all of those together. And that would be what I'd like you to write about on a short answer essay question about what's actually, why is this happening? And it doesn't just happen one year, right? It's happening over and over and over again. And it's happening right now. So, this is kind of a doom and gloomy sort of picture for sure. This is saying that climate change could kill off 1/5 of the world by the end of this century. And most of you are probably going to be around by the end of the century because people are living longer and longer than they ever did before. And that's kind of scary to see that. And, are you going to be part of the solution, or are you just going to watch what happens? And hopefully after we finish this semester, you'll want to be part of the solution. So is there any good environmental news? Because I know sometimes this can get really, really sad in our class. And I try to give you all some hope because in 2015, the world came together and said, we need to tackle climate change globally because one country can't do much about it. It's a global problem. And so all the worlds came together, and including the United States, and we signed the treaty. And a lot of countries are already have been for a long time working very hard on their carbon dioxide emissions and other things that they could do to help with climate change. And so unfortunately, President Trump decided to withdraw the United States from the climate treaty in June of 2017. The only countries that did not at this time that have not signed or have withdrawn are Syria, Nicaragua, and the United States. Most of the other countries have either signed and or ratified and are working towards solutions. So I used to be the most apolitical person ever. I don't like politics. I don't like paying attention. I don't like when people call each other names. I don't like any of that. But what I do think is because so many of you are of the age to vote, and whether you're in the United States or whether you're in China, when you're selecting your representatives and your leaders, you need to take time and see, first off, do they know anything about environmental science? Do they know anything at all about what's happening in the world about the environment? It does affect all of us. And so if a person is, for instance, a climate change denier, they say this isn't real, this isn't happening, then you know that they're not going to be paying much attention to it. So you need to make sure that you at least see what their policies are going to be, right, before you vote. And a lot of people don't. They are interested in other things. They're interested in employment. They're interested in taxes, things like that. But, the environment is going to impact everybody equally, whether you're rich or whether you're poor. And so we really need to make sure that we're electing good people that have, some kind of science background, or at least are willing to listen to scientists. And so the election's coming up soon, and I think you should pay attention to what everybody who's running for office is saying about the environment, and then listen to what they think, and then you decide who to vote for. I want you to be informed. Don't just listen to one side or read a little headline news. Environmental science is very, very complicated. There's lots of factors that play together. Everything is connected together. So try to use high quality journals, high quality sources. Don't just get stuff off of Twitter or Facebook or wherever. I do know that some of these problems are depressing, but try to stay involved and try to pay attention to things. You can make a difference. You really can. Individual people can make a difference. So again, start watching the news even if you don't want to. It's good for you. Every single day there will be something related to environmental science. There really will be. So this slide is from your book, and this will be the last slide from today's lecture. But it reminds me to tell you, in your books, a lot of people just skim through and they don't really pay attention to a lot of the the figures, a lot of the tables, things like that. I can tell you that an awful lot of your homework and quiz and exam questions will come from figures. So it reminds me to tell you to actually like spend a little time in studying them, okay? So this picture, this graph is telling you that we rely on natural resources. These are things that we need for our own survival. There are renewable and non-renewable natural resources. So renewable ones, they can be replenished over pretty short periods of time. Non-renewable natural resources are not available once they're gone. Once we've used them up, they're gone, and we can't make more of them. So in the three photographs here, within those text boxes, it's giving you examples of inexhaustible, exhaustible, and non-renewable natural resources. So this will, you can, I don't know how you would want to word a question, but I can tell you that the questions about these three figures come in play several times throughout the semester. So if we look at what is considered to be an inexhaustible renewable natural resources, it's basically all the alternative energies, right? Solar, wind, wave, and geothermal energy. We're not going to run out of any of those. Those are considered to be inexhaustible. And that's a big solar array panels that are in that photograph. The middle one tells you that these are things that can be exhausted. We can use them up. Fresh water, forest products, biodiversity, and soils. And we can, if we do not manage those carefully, we can deplete those, and they won't be renewable anymore. And then the non-renewables are basically fossil fuels and minerals. So crude oil, natural gas, coal, those are the fossil fuels, and then minerals. And we can actually use all of those up, and once we have, they're gone. And so take some notes on this. Another thing that you might want to do, I know I talk kind of quickly, maybe print out or have your PowerPoints up, and in the bottom there's a place where you can actually take notes. So you can take notes right on the slides while we're going through this, and that might be a good way of keeping up on the lecture material. So that's the end of our first lecture. I'll send you out the video link, and so our first week of class starts on the 31st, and so you should be finishing up chapter 1 by Wednesday. So we'll have this lecture, and then early in the week, next week, I'll post the second lecture. Then it's time to do your homework, and it's time to take a quiz. So everybody should be registered for mastering so you can do your homework and your quiz. I've sent you out a couple of announcements how to do that, and I will talk to you the next time. All right. Bye-bye.